amazing students there. I welcome you to Eko Learners Support for WAEC and NECO candidates. Today's class is going to be a fascinating experience. I am your humble chemistry instructor, Rashid Jimo. Are you ready? Come on, let's go.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Like I said, today we're looking at a very fundamental topic to so many things in chemistry. This particular topic, you use it in redox, you use it in electrochemistry, so many connections for this particular topic, and that's why you must know it right now so that you can continue to grow, all right, and excel in this wonderful field. So I want you to pick your pen and your notebook, write the topic and today's date down as we explore this topic together. We've set these learning objectives for ourselves so that we can evaluate how far we are able to achieve this at the end of the lesson. 1, you should be able to define oxidation number. 2, you should be able to solve oxidation number problems and explain the steps involved to your peers. I'm challenging you that at the end of this video, you will become a master of oxidation number and you will be able to even teach a lot of your peers. I hope you are really ready. 3, use the concept of oxidation number to explain rusting as an oxidation process. To guide our instruction, we are going to be using these keywords. Please write them down and find their meanings. Valency, you may want to watch our previous video on valency to have a lot of graphs about this. Oxidation number, which is the charge on an atom. Oxidation is the process of loss of electron. Reduction is the process of gain of electron. Let's start with an icebreaker activity. What can you see on the screen here? Did you say collaboration? Fantastic. That's the right word to use. This is collaboration, and that is the world we live in today. If atoms can think about collaborating, why can't we as humans? Because collaboration is better than competition. So, I have sodium with its oxidation number to be +1, chlorine -1, oxygen -2, hydrogen +1, calcium +2. What I want you to do, my dear student, with these numbers is actually to collaborate. Make sure the atoms are able to exchange their oxidation number and give me at least 5 of such compounds that will be formed. Pause the video right now and go ahead with the task. You're welcome back. So I asked, how many compounds were you able to form as a result of these atoms collaborating? All right, so let's find out how you fared with the activity. Okay, I hope that you have, as part of the answers, that you are able to form sodium chloride, hydrogen chloride, okay, water, okay, between hydrogen and oxygen, calcium chloride, and so many other compounds that you can form from this list of atoms. So let's move. Okay. Now, this is an inspirational quote to inspire you. It was given by Ellen Keller. It says, alone we can do so little, but together we can do so much. Still talking about the power of collaboration. This is what the outline of our lesson looks like. And don't forget to wait till the end so that you can also participate in the top 5 exam-style questions. Don't forget your periodic table. You must have a copy of it anytime you are reading your chemistry notes. So what is oxidation number? Okay, as its name suggests, we have so many numbers in chemistry. We have atomic number, we have mass number, okay? We have oxidation number. Oxidation number simply indicates the charge of an atom in a compound. That's exactly what it is the charge on an atom in a compound. And it helps us to understand how electrons are transferred between atoms in chemical reactions. Don't forget, it's all about collaboration. It's all about bonding. When atoms interact together, they use the oxidation number. So write this definition down in your note. As you can see in the picture there, hey baby, you want to swap oxidation number? Okay, they are actually speaking. The atoms are speaking, making sure that they exchange their oxidation number. Who are you going to exchange your oxidation number with today? That joy, that excitement, that knowledge of chemistry that you have just acquired, are you going to share it? Are you going to transfer it? I trust you to be able to do that. IUPAC nomenclature, these are some applications of oxidation number. Very, very important to so many things in chemistry. IUPAC system of naming chemical compounds. You cannot name some complex inorganic compounds without you having an understanding of the oxidation number. We also use it to know which atom is oxidized or reduced in a redox reaction. That's another special kind of reaction, which oxidation number is central to. 3, you will need it to understand how electrons are transferred between electrodes in an electrochemical cells, what we call the batteries. It's very also important in environmental chemistry and finally in so many industrial applications. And you can now see how important this topic is. All right, let's look at some real-world application of oxidation number. What can you see on the screen here? You are right. It's simply rusting of iron. You have a new bicycle, and after several exposure to air and water, it becomes brownish. What has happened there is oxidation. Chemically speaking, what that simply means is that iron has changed its oxidation number from what it is here, okay, where it is 0 here, and it has now turned to what? To +3. This is iron in a free state with oxidation number 0, and this is what you call rust. This is what you see as that brown coloration, okay? Iron changing oxidation number to +3, and that is iron 3 oxide. So the next time you notice any rust around the chains of your bicycle, then you know what is really what causes that is simply oxidation, okay? And this is usually a major problem. Now, what are the rules that you need to be able to calculate oxidation number? I have put the rules there in visuals so that you can really grasp them, okay? The first and the most important is that when you have the oxidation number of atoms together, it sums up to what? To 0. Please take note of that. The sum of oxidation numbers of atoms in a compound is equal to 0. 2, oxidation number of hydrogen is +1. And the question is, why do we need to single out hydrogen to know its oxidation number? It's because hydrogen is present in most compounds, and it is important that you know what its oxidation number is. Oxygen is also another very common element, and you must know that in most of its compounds, the oxidation number of oxygen is -2, except in peroxides, which I'm not going to dwell so much about. There's also an exception for hydrogen, except in hydrides, okay? where it is -1. But in most of their compounds, hydrogen is +1, oxygen is -2. How many rules have we taken down now? Fantastic. 3. Let's move to the fourth one. Oxidation number of an ion is the charge on it. And I want you to do that. Do that at home, right? The oxidation number of an ion is the charge that it is carrying. When you see an ion, for example, you have an ion such as, pick my pen, you have Al3+. That's an ion. An ion is actually an atom that possesses a charge. Okay, so the oxidation number of this ion is simply +3. Isn't that just straightforward? Okay, it's just like the cap you're wearing. The oxidation number of an ion is the charge on it. All right? Oxidation number of an element in a free uncombined state. When an element is not in form of a compound, is existing alone. You saw earlier the example we gave of the rusting. The oxidation number of iron. Iron was actually on its own. And that's why its oxidation number is what? Is 0. When you have an atom participating in a reaction and it is alone, is a Liverpool fan, for example, never walk alone. It's standing alone there. Its oxidation number is what? Is 0. Let's move on. Okay? The next rule, oxidation number of group 1 elements. Of course, that's why they are called group 1, is +1. Of group 2 element, like calcium, +2. Of the halogens, -1. These are the rules, and I want you to really spend a lot of time to get familiarized with these rules. Okay, so I put the rules there in a very concise way. These are the most important rules. And once you uphold the rules, definitely you perform magic. Now, let's do the magic by calculating oxidation number of some compounds that are here. Okay, are you ready? Are you ready? If you're not ready, then pause the video and go through the rules again, because you will need the rules to be able to do this. Let's start with the first one. That is Na2SO3. The first rule says that the sum of oxidation number of atoms in a compound, when you put those atoms together, their oxidation number will be equal to 0. So let's just separate all the atoms. So this is Na2 plus S plus O3. They will all be equal to what? You are right, 0. That's the first rule. All right, so we are asked to calculate the oxidation number of sulfur. Do not forget that. So it is the sulfur that we are looking for. So the oxidation number of sodium is going to be +1. It's fixed because sodium is in group 1. So this is going to be +1, but there are 2 of it there, times 2, put it in parentheses, plus, let's represent our sulfur as S. Okay, then plus, what is the oxidation number of oxygen from the rules? Bravo. Give yourself some cheers. -2. So that's -2 times 3. Okay, and that equals to 0. So +1 times 2 is +2, plus S, plus times minus, minus 2 times 3, that is 6, equals to 0. So you have +2 minus 6. Okay, that will give S minus 4. Yes, +2, you have 2, and then -6, you're owing 6. When you pay your debt, S minus 4, okay, equals to 0. Then when -4 goes to the other side, it becomes +4. This is how you do it. Simple, right? I'm going to do the second, and I will expect you to do the third and the fourth and the fifth, and give me your feedback in the comment section. So let me just do the second one here. Yes, this is A. Let's quickly do the B now. So we have H2, S2O7 equals to 0. Okay, so we do the same by splitting. H2 plus S2 plus O7 equals to 0. Which element are we looking for its oxidation number? Fantastic, sulfur. Okay, so we underline the sulfur. All right, so hydrogen is plus 1 from our rule. That's plus 1, plus 1. That is plus 1 times 2. I need to erase that. Plus 1. Okay? Plus 1. So hydrogen is plus 1, but there are 2 of them times 2. Plus S2 plus oxygen is minus 2 times 7 equals to, put it in bracket, equals to 0. So this is plus 1 times 2 plus 2 plus S2 plus times minus, minus 2 times 7, 14 equals to 0. When you take away plus 2 from minus 14, you are going to have S2 minus 12 equals to 0. Okay, S2, by taking this to the other side, S2 becomes plus 12. If you divide both sides by 2, because you have to find oxidation number of sulfur atom, not disulfur, sulfur atom. So that takes care of this, cancel this, then sulfur is going to be equal to plus 6. In another video, I'm going to challenge you to actually give the names of these compounds. So I expect you to be able to now use this to be able to do C, D, and E. E is even straightforward there because you have an element in a free, uncombined state. So well done, you're doing fantastically well. So let's move to the top 5 exam-style questions. Okay? What is the oxidation number of boron in this compound? Okay, very simple. Don't forget the rules. So we will still be applying the rules. Okay, so write out all the compound, write the compound down, and it will be equal to 0. Why is it equal to 0? Because it's a compound. But if it is an ion, for example, like one of the questions that I asked you to do earlier on, like this now, what you have to take note of here is the fact that the sum of the oxidation number is not going to be equal to 0 here because this is a radical. So this is have to be S plus O3 equals to minus 2. I wasn't willing to tell you that before, okay? But I mean now, that should help you to be able to do that very well now. It's going to be equal to the charge on it, okay? And not a 0. So let's move to the question that we are working on. So this is a compound, so that equals to 0. So your sodium is plus 1 times 2 of them. You have to find the oxidation state of boron. So plus B4 plus oxidation number of oxygen is what? Minus 2, of course. Minus 2 times 7 equals to 0. Plus 1 times 2 plus 2 plus B4 plus times minus, minus 2 times 7, 14 equals to 0. So you have plus 2 minus 14, that is B4 minus what? Minus 12 equals to 0. Then B4 equals to, take this to the other side, plus 12. Divide both sides by 4. Okay, and B is going to be equal to what? Plus 3. Did you get that? Correct. Plus 3. So let's move and look at the next one. What is the oxidation number of chlorine in this? So I'm not going to do the work. I'm just going to give you a very easy way to be able to figure this out without having to do the workings. Okay, it's about balancing the charge. So we want to know the oxidation state of chlorine. So the oxygen is the negative part of this compound. So that is minus 2 times 4. Okay, hydrogen is plus 1. And everything must be equal to 0. Are you with me? So if hydrogen is plus 1, this is minus 2 times 4. That's minus 8. Okay, so what must chlorine be? So that when you add that number to plus 1 and you take it from minus 8, it's going to be equal to 0. Did you say plus 7? Amazing. You're really getting good at this now. Fantastic. Yes, plus 7. So sometimes you might just, as a clever guy, you might be able to just figure it out and balance the charges, okay? But if it is in a theory, you have to work it out. Which oxide of nitrogen has the highest oxidation number? So this means that you have to work out, okay, the oxidation number of each of this compound and find which one does nitrogen has the highest. So let's quickly do that. Okay. All right. So this is going to be N. This is minus 2 times 2. That would be minus 4. But because there's already a minus 2 here, so the oxygen will be minus 2. And this is going to be plus 2. And we can work it out too. Okay. Equals to minus 2. And that is N plus minus 2 times 2 equals to minus 2. That is N plus times minus 2 times 2, 4 equals to minus 2. This is N equals to minus 2 plus 4. And N equals to what? Plus 2. So here it is plus 2. Here I know it's plus 4. Because if you look at it, this is minus 2 times 2, that's minus 4. Definitely this has to be plus 4. Okay, here is going to be, oxygen here is minus 2 times 5, that is what? Minus 10. Here is going to be plus 10 divided by 2, that will be what? Plus 5. Here, oxygen is going to be minus 2 and nitrogen is going to be what? Plus 2. So which one does this have the highest oxidation state? The correct answer is option C. Fantastic. Well done to you. Give yourself some encouragement. Oxidation involves a or an dash in oxidation states. Very simple. Oxidation involves an increase. Okay? Whenever an atom undergoes oxidation, its oxidation state or oxidation number increases. Okay? While reduction, as the name suggests, reduction, moving from a high to a low, okay, involves what? A decrease in oxidation state. You are going to learn more about this in redox reactions. Let's look at the last, but not the least. Yes, the true or false question. Okay? Oxidation number of an element can be 0. Is this true or false? Which of the buttons are you going to press now? Oxidation number of an element can be 0. Did you say false? Oh, I'm surprised. Why? Because one of the rules is that oxidation number of free, an atom in a free uncombined state, is 0. We saw for iron in the rusting process there. The answer should be what? Should be true. Well done, well done. That's a good effort. The answer is true. So press the true button there and move on. That's the green light. So these are some common mistakes that you need to watch out for. One is confusing valency with oxidation number. They are never the same. Forgetting to apply the rules. No rules, no way, no answer. 3, always double check. Even after doing the calculation, check and be sure that everything is intact. These are the quick tip for you there, that the sum of oxidation number of atoms in a compound is equal to 0 when we come together as humans and we put all our effort, our love, our resources together. What it is called in Africa as Ubuntu. I am because you are. We achieve so very much. These are the key takeaways from our class today, and I thank you very much for your efforts in ensuring that you build a resilient and sustainable future for yourself and for the rest of us. I'll see you next class. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.